Welcome to Chapter 6, Joint Distributed Random Variables. The first definition we cover is the joint CDF, Joint Cumulative Density Function, Distribution Function. We have a pair of random variables. They can be either discrete or continuous. We denote them X and Y. The joint cumulative probability distribution function, the joint CDF of X and Y, is defined to be, so notice here that we write capital F for any CDF that we do. We can add subscript here to indicate it's the joint CDF, and it's defined to be the probability that capital random variable X is smaller than some value X and Y is smaller than some value Y. Right? So graphically, we can consider this, and pretty much the joint PDF is looking at the shaded region that I highlighted over here. There are a few properties, important properties. From the joint PDF, if you want to only look at one of the variables, and that's what we mean by marginal. So if you want to get the marginal CDF, you can get, say, for fx, you can consider all the possible values of y. So you only focus on x over here. For the marginal CDF of y, you consider all possible values of x and only focus y over here. And lastly, if you want to work with joint probabilities, and earlier we defined the joint CDF to be x smaller than or equal to x and y smaller than or equal to y. But then if you want to find the other side, what you do, this is actually very similar in some way to the exclusion-inclusion property that we covered before about probability. So you use 1 minus the marginal of x minus the marginal of y, but because you actually delete it twice, you're going to add back of the joint. Okay, so try to sketch it out to see if there is a way that you can convince yourself that the joint probabilities is indeed in this expression. So here is a multiple choice question for you. Please use the joint CDF fx to represent this particular event. So this is when x is in a range and y is in a range. Okay, we want to find the probability of that. So A, B, C, D, please indicate your choice.